In the previous episode, we learned how the shorter fibers are made into long yarns with the help of mechanical spinning. Now we will see how the fibrous material is converted into the fiber and then it is spun into yarns. This is called chemical spinning, and we deal with this chemical spinning in this episode. Fibers are manufactured by observing the silk formation in nature. So, many fibers which are available in the market today, they are either man-made or synthetic, except those which are available in fiber form, especially the natural fibers, natural cellulosic or protein fibers like silk and wool. They are all available in the form of fibers, but whereas these nylons, polyesters, polypropylene and all other fibers are not available in fiber form. And so, the chemical spinning is applicable to these fibers, because the manufacture of the fiber is also involved in it. All these fibers are mostly filamentous in nature because they are manufactured as filaments. Unless it is blended with some other fibers, they are all produced in a filament form only. When they are blended with other fibers, they are cut into smaller staple lengths and then blended with the other fibers. These manufactured fibers have different polymers. So, the polymers are being produced and they will come to the chemical spinning factories in the form of chips or in the form of powder. And so, these chips and powder should be made in the form of a liquid, and then only the liquid should be actually made in the form of a linear polymer, so that it becomes a filament. In order to do so, the particular polymer is either melted or dissolved in either volatile or non-volatile solvents, and then it is made in the form of a solution. And for free flowing of this solution required, because this polymer is extruded through the holes of a spinneret. It is called as a spinneret, which is a small metal plate having fine holes. And so, the particular polymer which is in solution form is made to pass through the holes of the spinneret, and then it gets solidified when it comes out of this thing, and thus you will get a continuous filament out of it. Depending upon the type of polymer that is used and also the type of material that is present, whether it is a volatile solvent or a non-volatile solvent, the methods differ. And so, it is sometimes this chemical spinning is also called the extrusion methods. That is, we have to actually make it into solution and then it should be extruded through that. And so, extruded technology, this is also called as. Based on the method of making the polymer into solution, the methods differ, and we have three methods over here. One is the melt spinning, dry spinning and wet spinning. These are the three methods generally conventionally employed for production of most of the artificial fibers available in the market today. Coming to the melt spinning, this melt spinning is the most simplest method, because it involves only melting the polymer and then making it in the form of a solution and extruding through the spinneret and then cooling it in air. When it hits the air, it gets cooled and solidifies. It solidifies in the form of a very thin filament. And it is also very inexpensive, because we are not using any solvent, or solvent recovery is not required in this method, and so this is the most inexpensive method. And fibers like polyester, nylon or polyamides and also polypropylene are produced by this melt spinning process. In this, first polymer chips come from the chemical factory, and they are placed in a hopper, and several chips from different machines will be brought in and put through a hopper, and then through the hopper they will get mixed to get a uniform polymer, and then they are made to fall on a hot grid. When it falls on the hot grid, it melts, and the molten solution, then it is collected and then it is filtered in order to remove any suspended impurities which will interfere with the holes of the spinneret. They may block the holes of the spinneret and stop the formation of the filament over there. And so, it will be first filtered to remove all the suspended particles and then vacuum treated. If it contains a small air bubble, that also will interfere with the formation of a longer and continuous filaments. And so, this is vacuum treated to remove the air bubbles, and then it is stored in the storage tanks. From the storage tank, the molten solution, that is a free flowing polymer, is made to pass through the holes of the spinneret. So, from the holes of the spinneret, it comes out in thin form and it becomes a filament. It gets solidified by hitting the air, and then it becomes a filament. And when you check the particular filament, it will not contain alignment of the molecular chains within that particular filament. And these molecular chains need to be aligned to the fiber axis in order to make it more stronger. And so, after melt spinning, mostly these materials are cold drawn in order to improve the fineness as well as the alignment of these molecular chains to the fiber axis. Usually, it contains again two sets of rollers, and one with a difference in the speed, and the second one always revolves at a higher speed than the first one, and usually here maybe around 4 times higher speed than the first roller. So, that when the filament is fed through it, and the second one will pull it 4 times more than its length, and thus it attenuates the filament and also align the molecular chains to the fiber axis, and thus the filament that comes out is wound on bobbins or whichever package they want, it is made and then taken off from the chemical spinning. And here one thing is that the free flowing liquid, when we say free flowing liquid, sometimes what happens, if it is a melting temperature, it is just not enough, that is why they go 30 degrees centigrade more than the melting temperature, so that there is no possibility of it getting it more viscous. But actually if it is more viscous, it contains the more alignment of the molecular chains inside. But if the more viscosity is there, it is very difficult to make it to pass through the spinneret. And so, usually the temperature of the polymer will be 30 degrees centigrade higher than its own melting point. The second method of chemical spinning is the dry spinning. So, when the polymer is of not melting type or thermoplastic, and we have to see whether there is any volatile solvent that is applicable to that particular polymer. If it is so, then we can go for the dry spinning. This is also a simple method wherein the polymer is dissolved in a solvent, extrudes through the spinneret, holes of the spinneret, and then it gets solidified through evaporation of the solvent. In this dry spinning, the solvent is a volatile one, and around 25% of this solvent is required. And so, the particular polymer will be dissolved in this solvent, and then a free flowing liquid is formed through that, and then the free flowing liquid is again filtered in order to remove any suspended impurities, because it interferes again with the formation of a continuous filament, and also vacuum treated to remove air bubbles, and that again interfere with the formation of a continuous filament. So, when it is treated with all these things, and then it will be stored in the storage tank, and when the manufacture starts, the free flowing solution from the storage tank is forced through the holes of the spinneret into a hot chamber. In this hot chamber, the hot air is in circulation or nitrogen may be in circulation, and this one will be able to take up the solvent that is present in the fiber, in the filament, and then it takes it off to another chamber. Thus, the filament that comes out will be solidified by removal of the solvent in that particular thing. In this process, actually the 10% of the solvent may be lost or may be present in the fiber itself. But it is considered to be a costly one, because the whatever solvent that is being used here, they are all very costly and maybe inflammable also, and sometimes maybe toxic also. So, these solvents cannot be polluting the air, and so it will be collected in some other chamber, and then solvent will also be recovered and then again used for the manufacture of these materials. And actually when you see the cross section of this fiber, like melt spinning, it will not have the shape of the hole of the spinneret. If the whole of the spinneret is in star form, in case of melt spinning, you find that it will have only that particular cross section. But in case of these dry spun filaments, you find that the same cross section will not be there, and sometimes it may become lobular, because the solvent which also forms the part of the filament is being removed, and so it may become lobular, and then it may have some other qualities that come up. The third method of chemical spinning is wet spinning. When the polymer is not in a stage of melting or dissolving in a volatile solvent, then non-volatile solvent is employed. Since a non-volatile solvent is used, we cannot evaporate that particular one, and so a chemical bath is required in order to coagulate the particular polymer, so that it comes out in the form of a thin filament, and so it requires the chemical bath for this particular non-volatile solvents if they are used. And for this reason, we need spinnerets of high quality and which are corrosion resistant, because the particular spinneret has to be placed in a chemical bath, so that it is able to pass the particular polymer liquid through their holes into the chemical bath. So, in order to resist in that chemical, and the particular spinneret has to be made of some precious metal, and which again requires huge investment on the part of the manufacturer. And so, in this process again, the non-volatile solvent is used to make the polymer into liquid form. Then there will be a small trough where you have the chemical bath, and which usually contains a dilute acid, and the spinnerets are placed in that, and then the solution is first again will be filtered to remove all the suspended particles which interfere with the formation of the continuous filament, and then also vacuum treated to remove the air bubbles. Again those things will be interfering with the getting the continuous filament, and thus it will be stored. And so, when the manufacture begins, the polymer, which is a free flowing one, which is in the form of a solution, will be forced through the holes of the spinnerets. And one thing we have to observe here is that the holes are very, very thin when compared to the holes of the other two methods. And so, it may contain even 20,000 holes in a small spinneret. And so, the liquid that passes through the spinneret in the form of a thin linear structure will get coagulated in the chemical bath, which contains a dilute acid, and sometimes even some additives are also added to improve the handle of this polymers. It depends upon the fiber which is being manufactured by this particular process. And so, it comes out, and then it is wound on some bobbins, and then which later is washed and again wound on final bobbins. The fibers that are manufactured using the wet spinning process, that is using non-volatile solvent, is viscose rayon and polyacrylonitrile fibers. Actually, the cross sectional shape of these fibers will be serrated, because the coagulation occurs in the this bath, and thus they assume a new shape of a serrated effect, and this will be seen in the form of long lines on the longitudinal section of the fiber. Even though non-volatile solvent is used here, they are much cheaper, and so the recovery is not being attempted by the manufactured. So, recovery is much more costlier and compared to using that solvent, and so recovery is not being attempted in this particular process. Additives used in polymer solutions. Different types of additives are used in polymer solution in order to provide different characteristics to the polymer. Sometimes they use delustering agents, or sometimes they use optical brighteners, or sometimes dyes are being used, and sometimes anti-static agents that are being added to the polymer solution. They will bring in certain characteristics, and so that the versatility of this fiber increases. When you take the delustering agents, the filament has can reflect totally the light back, and thus it becomes shiny, because these come out of the spinneret holes, and this will be very smooth and unlike all the natural fibers. And so the luster that is coming out, that shining in the filament should not be there for all the fabrics, and because it is not liked by everybody and for all the purposes. And so these filaments are made dull or semi dull by use of some delustering agent such as titanium dioxide. This titanium dioxide, when it is added in the pigment solution, it gets dispersed uniformly, and then it gives us black spotted effect, and when you see the fiber under microscope, you will find that there are black spots. And so when the light ray falls on the filament now, and the black spots over there, the titanium dioxide will absorb part of the light ray and then reflects only part, and thus it can be controlled, whether the amount of luster that can be there in the filament can be controlled by addition of the different percentages of the titanium dioxide. And thus, and especially for dyeing, when you dye the fiber, and when if it is too lustrous, and you find that the particular color will not be looking very good, so delustering is compulsorily done for all dyed fabrics. Dope dyeing, or it is also called solution dyeing, because it is addition of the dye within the solution, and it is called solution pigmenting also. So this is done when a single colored filament is required at large quantities, something like making a khaki material or navy blue material which is being used in large quantities. For production of that, usually this dope dyeing is employed. So you will get a single color after of the filaments come out through the whole solution will produce only the filament of that color. And so when it comes out, that has to be employed for production of the fabric of similar type, and so maybe sometimes it is difficult to utilize the whole material. And so solution pigmenting is limited, and only when one color is required at larger quantities, then they go for it. And in this, the filament, the pigment which is present should be made of very fine particles, otherwise these particles will again interfere with that. And with the use of this pigment inside the solution, it will be very cheap, because there is no wastage of the color, wastage of the dye over there, and also the color fastness is very good, because the color becomes a part of the filament, and that is why it is going to be very, very fast. And so sometimes this is being used by the military and for other purposes. Then other additives, like we have some anti-static agents, and also optical brighteners are present. So these optical brighteners are added, or whiteners, they are added in order to produce very good white goods. Sometimes they call it as whiter than new. That means that these optical brighteners are added in the solution to make them look white. And so even after use for some time also, you find that the fibers will not lose that whiteness, and so the white goods will be maintained as white by the consumer, and so consumer will be happy to have these things. And so optical brighteners are being added, and especially to the white shirting and other things, where it should be maintained as white throughout. And then additive like anti-static agent, these things are added in order to make them to dissipate the static electricity that is produced. You know, like polyester and other fibers which are having very low absorbency, these fibers cannot dissipate the electricity that is being produced, because you know that the static electricity is being produced by rubbing the fabric against each other and against itself. And so, the electricity, if it cannot be conducted away, it will be stored on the fabric and it creates lot of trouble to the for stitching as well as to the wearer. These anti-static agents, when they are introduced into the filament, then it will be able to dissipate the electricity that is being produced and make the wearer comfortable. So far we have seen how the chemical spinning has taken place, and also that here what we have to remember is that the fiber material is not in a fiber form, and so we are manufacturing the fiber as well as we are spinning it the filaments into a long continuous yarns that are required for making the fabrics.